Welcome everyone to another episode of Elite Ledger Media. I'm your host, Mark Johnson, and as usual, we have our expert researcher, Ivo Kausen. Today we dive into something quite fascinating at the intersection of healthcare and artificial intelligence. We're talking about the application of a hierarchical multi-agent reinforcement learning framework, or HMARL, in multi-organ disease care. This approach promises to revolutionize the way we manage complex diseases. But before we dig into that, I want to encourage all our listeners to share their thoughts, stories, and experiences related to this topic. We aim to build a participatory community, so don't hesitate to join the conversation. So, Ivo, shall we kick off our topic for today?
Absolutely, Mark. And thanks for the warm welcome. It's always a joy to unwrap these complex topics and make them digestible for our audience. So, to get us started, let's talk about what HMARL is. The Hierarchical Multi-Agent Reinforcement Learning Framework combines hierarchical reinforcement learning and multi-agent systems to address complex decision-making problems, especially in healthcare.
That sounds like quite an advanced blend of strategies. Could you break it down a bit for us? How does this come into play in a scenario of multi-organ disease care?
Of course, it all starts with understanding that managing multi-organ diseases is complex due to interactions between different organ systems. The HMARL approach aims to address this complexity by providing a holistic view of the patient's condition and optimizing treatment strategies across multiple organs. Imagine multiple agents, each responsible for a specific organ, working collaboratively to optimize the overall treatment plan. Now, this approach allows for dynamic adjustment of treatment strategies based on real-time data and patient responses.
That's quite intriguing, and it sounds like it's a massive step towards personalizing treatment, isn't it?
Indeed, Mark. By considering the interactions between different organ systems, HMARL enables personalized treatment plans tailored to the specific needs of each patient. Not only that, but the real-time adaptation allows for improving patient outcomes, as treatment strategies can adjust dynamically based on data.
Personalized treatment and real-time adaptation all sounds promising. Can you give us a couple of examples where this methodology is being used to improve patient outcomes?
Sure. There have been applications in optimizing treatment strategies for complex diseases like cancer and sepsis. For instance, considering the interactions between different treatment modalities and organ systems, the HMARL framework has demonstrated its potential in improving treatment efficacy. Also, in the realm of disease diagnosis, the use of multiple data sources can provide more accurate and timely diagnoses, leading to immediate intervention, especially in instances where it is crucial.
That's pretty impressive, Ivo, but I assume there are some hurdles we need to overcome to make this framework practical in real-world settings, aren't there?
You're right, Mark. As with any innovative approach, there are challenges. In the case of HMARL, ethical and safety concerns arise. It's crucial that the framework doesn't harm patients, which requires rigorous validation and testing prior to clinical deployment. There's also the computational complexity of modeling multi-organ interactions and integrating the framework with existing healthcare systems, which poses logistical challenges. Nevertheless, the potential benefits make it a key area for ongoing research and development.
Well, that's a wrap then. Many thanks, Ivo, for your insights. And our listeners, please continue sharing your experiences and thoughts on this topic. It's your stories and feedback that make our conversations here all the more rich and engaging. Until our next deep dive, folks, this is Mark Johnson signing off.